Are you all able to still hear me? Yeah, Archana, we'll do one thing, one day we'll just have the sessions from your end. During our revision classes, we'll definitely have these voice sessions. So, but right now when it comes to discussing with audio, it would, distract us a lot from coverage of the portion. So let's concentrate on our portions right now. Let's have this chat as a communication medium, and let's go ahead with the voice chat or something during our discussions. We'll be having a lot of discussion classes once we complete our portions. Yeah. In last class, probably you would have covered embryology, and I assume many of you must still be feeling, that I don't know embryology, isn't it? Actually, talking about embryology, we come into a hitch. The problem that we face is about the limitation the limit we have to set while reading embryology. When we talk about embryology, there's a lot to imagine because we are not able to see the embryo directly. So there's a lot to imagine and to understand. But we don't have that much time to go into that detail. So sometimes we may have to restrict ourselves as far as MCQ preparation, as far as entrance preparation is concerned. So again, in today's class, there may be some areas which may need a bit more elaboration. But today, what I will be doing is creating a framework. We may go into further elaborations with the questions and back reference, as I always say. Is it okay with you all? Shall we go ahead with the session? Okay, we have been talking about the buccopharyngeal membrane in the last class, probably the formation of buccopharyngeal membrane. It consists of which two layers? Ectoderm and endoderm. Without the in-between mesoderm, we have the buccopharyngeal membrane. This buccopharyngeal membrane ruptures at 27th day, 27th or 28th, right? So, and when we talk about the development of tooth, what we need to know is underlying the ectoderm, underlying the oral ectoderm, we have the connective tissue that is derived from the neural crest cells. I think so you had been talking about the development of the neural crest cells and their migration in the oral zone, in the pharyngeal arches. So these migrated neural crest cells, they are the one responsible for the development of ectomesenchymal condensation below the oral ectoderm. Okay. This ectomesenchyme is important because it is involved in the development of tooth. So this is the ectomesenchyme. At the 6th week, we have the dental lamina formed by selective proliferation. What is important here is this word selective proliferation. What happens is, you have this layer of oral ectoderm. Below that, you have the connective tissue. In the oral ectoderm, you have the cells which are dividing in this plane, so that the oral ectoderm is kind of growing in size. But at a particular point, what happens is these cells, they change the plane of division to this. Because of the change of division, what happens is there is thickening that develops. So if I draw it, are you able to see the diagram over here? If you see in yellow, I have drawn the cells which have changed their plane of division because of this change in the plane of division. Rather than growth in this direction, we have a thickening in this direction. All this happens because your cells were first dividing in this direction. Now they have changed their plane and now they are dividing in this direction, and one cell moves in this direction, because of which there is thickening that develops. This thickening gives the rise to dental lamina. Is that clear, Gaurav? Yeah. Now when we talk of the dental lamina, what happens is, this is what we see in the cross section. This type of thickening is what we see in the cross section. When we happen to see the archways, your dental lamina is something of this shape. It's a horseshoe shaped structure, a thickening throughout your in the alveolar process. Alveolar process develops after the dental lamina, but to imagine, you can just imagine it is in this region you have the thickening, right? So after you have this thickening, from this thickening you again have the localized thickening develops, which further give rise to the tooth bud. From the tooth buds you get your deciduous teeth. From the deciduous teeth later, on the lingual side, you have the extensions that give rise to the permanent tooth buds. These permanent are the subcutaneous tooth buds. But there are certain permanent teeth which do not have predecessors. Do you understand what does it mean when I say the certain permanent teeth which do not have predecessors? I'm talking about the permanent teeth which do not have preceding deciduous teeth. Can you give me the examples? No, Prajakta, it's not premolars. It's molars. Premolars, yeah, premolars have deciduous molars before them. But permanent molars do not have any teeth before them, and they developed by the extension of these dental lamina here, backwards, this direction. Right? So this is what the information we have is, the dental lamina is formed by the change in the plane of orientation, division, change in the plane of division of cells, and this thickening of the dental lamina gives rise to the deciduous tooth buds. Following the deciduous tooth buds, you have the lingual extension giving rise to the permanent tooth buds. But there are certain permanent teeth that do not have predecessors, and they develop from this distal extension of the dental lamina. These 3-4 points, is this clear? Yes. Now do you see in this diagram, what do we see here is, this is an oral epithelium that gives rise to the underlying thickening, that is your dental lamina. Do you see this dental lamina over here? This is nothing but the thickening that gives rise to the teeth. The further permanent teeth developed by this backward extension of the dental lamina. And do you see these small projections over here on the lingual side of the dental lamina? These small projections are the permanent tooth buds which would be coming later. On the front side of the dental lamina, you can say towards the side of the lip, you see this depression over here. This depression or this downward growth is your vestibular lamina that gives rise to the vestibule, the labial vestibule. Is it all clear? Now what happens to this dental lamina? We have seen that this dental lamina is an undergrowth that forms because of the change in the plane of division of the cells. After it grows downwards, it gives rise to the tooth buds. After the tooth buds are formed, when the tooth is still forming, the dental lamina starts dividing. Excuse me for a second. I think somebody is facing a problem. Okay. What about this slide, Archana? This slide or the previous slide? Okay, yeah, we were talking that dental lamina develops as downward extension, and after it grows as a downward extension, it gives rise to these tooth buds. Once these tooth buds are formed, no, this dental lamina starts dissolving. Do you see this areas of dissolution over here? This is nothing but dissolution of the dental lamina. So ultimately, starting from its formation, the period of activity of dental lamina lasts for 5 years. This point is very important MCQ. After the initiation of tooth buds, dental lamina in that region degenerates. Now by chance, whenever we talk about any degeneration or dissolution, whenever we will be talking about tooth development, any dissolution will leave some of the remnants over here. These remnants of dental lamina in the later stages, yes, they are the rest of serrates after dissolution, and they are the one that may be responsible for the formation of eruption cyst later. Then what happens once we have these growth, that localized growth from the dental lamina giving rise to the tooth buds? This tooth bud progresses through the stages of development. These stages are actually continuous. You just cannot divide them. Okay, that this is where bud stage ends, so this is where the cap stage starts. But for the purpose of just easiness of reading, it has been theoretically divided into these stages. So there is no as such demarcation of the stages. This is just a theoretical division. So we have the bud stage, that is the initial stage. Now when we talk about the bud stage, what happens is you have the dental lamina, and there is just not like thickening giving rise to the tooth bud. This is the bud stage, wherein we do not see any particular differentiation of the cells. Then we have the cap stage. In the cap stage you have enamel knot and enamel cord. What are these enamel knots and enamel cords? This is herein what happens is in cap stage. Let me just go to the whiteboard. Let us make it a blackboard now. Okay, herein you have this bud stage. After that you have this cap stage, right? When we talk about the cap stage, what happens is you have the dense condensation of the cells, especially in this region. This is called as enamel knot. Now when we talk about the enamel knot, this enamel knot actually acts as a reservoir of the cells, reservoir of the multiplying cell that provides these cells for the growth of the tooth bud. You must be saying how fast this tooth bud is progressing. The growth is so fast. For that we need some reservoir of the mesenchymal cells over there. These are the provided by enamel knot, and this enamel knot actually extends upwards like this, making a structure that is named as enamel cord. Now when we talk about functionally, or you can say when we talk about the function or the differentiation of the cell, actually enamel knot is not as that different from enamel cord. It's just the extension and the location of these cells that has made us give them different names. So enamel knot and enamel cord, they provide the extra cells which are needed for division. Fine, so that makes our cap stage. Then we have the bell stage. Yeah, transient structures, whole stage, if you see the whole, these cells are transient. Ultimately what we will be having is the tooth. All the tooth forming cells would be dissolved and lost. Yeah, we'll be talking about enamel niche. Now, since Hemlata has taken out the topic of enamel niche, let me cover it over here itself. Enamel niche is, I'll just make a diagram. What has happened if this is your dental lamina and this is your tooth bud? Sometimes there had been seen that other than one connection, tooth bud was found to have one more accessory connection with the dental lamina. Are you getting me? This is a primary connection. Sometimes it was found that there was one accessory connection noted with the dental lamina. Between these accessory connection, you see this zone, this empty zone over here that was named as enamel niche. Okay, now enamel niche particularly is not any structure or anything, rather it was thought to be an artifact resulted because of the formation preparation of a slide in a particular plane. It's not exactly the connection, it's the space between those connections that was named as enamel niche. Is that clear? Yeah. So this enamel niche particularly doesn't have any function or anything, it's just an artifact kind of a thing. It may exist, there may exist different connections. The possibility of that is not so sure kind of. Next we come to the Bell stage. In Bell stage what we have is a proper distribution of the 4 layers, that is inner enamel epithelium, outer enamel epithelium, strata intermedium and stellate reticulum. Let's just have a look at how these 4 layers look. So after our cap stage, then you have Bell stage. As very obvious the name says, you have a bell-shaped structure. In the bell-shaped structure, you see the properly differentiated cells, the cells which are on the inner side over here, lying towards the dental papilla. This connective tissue zone inside the enamel organ is called as dental papilla. These cells which are just adjacent to this dental papilla, they are inner enamel epithelium. The cells which continue here on the outer side, they are called as, are you there with me? They are called as outer enamel epithelium. Then you have one more layer of cells that lie very adjacent to these inner enamel epithelium cells. What are these cells called as? Stratum intermedium. Perfect. So these cells are called as stratum intermedium. And then you have one more group of cells which lie between this outer enamel epithelium and stratum intermedium here. These cells are called as stellate reticulum. Actually they are given stellate reticulum the name at a particular stage of development. We'll be talking about it a bit later. Let me just go ahead with the slide right now. I'll come back to this. Okay. So let's just have a look in here. This was your bud stage wherein you had a small knot like thing over here. Then you have the cap stage. It was in cap stage we could actually locate the reservoirs of cells which were called as enamel knot and enamel cord. And then you have the Bell stage. In the Bell stage you could see all the 4 layers of the enamel organ. Then you have inside there is a condensation of the mesenchyme that is called as dental papilla, and again outside this enamel organ you see a condensation that is called as dental sac. Perfect. This condensation outside is called as dental sac, inside you have the dental papilla. Does that make all the terms clear? In the cap stage you cannot differentiate all the 4 layers. In the cap stage what you see is basically you can differentiate the cells. The outer and inner enamel epithelium have just started to form, but you can see the reservoirs of the cells. So actual differentiation or histodifferentiation is a feature of your Bell stage. Then in the advanced Bell stage, now when we talk about the Bell stage and when we see it in 10K, you don't see a definite division of Bell stage into early and advanced. But when we go ahead with organs, you will see the division of early Bell stage and advanced Bell stage. So some of the MCQs may be focused on this early and advanced Bell stage. So what happens is, in the early stage itself, we will be able to see the histodifferentiation. But in advanced Bell stage, your tooth germ, your enamel organ will take an exact shape of the tooth which it is forming. So your morphodifferentiation is a feature. Do you hear a lot of background noise? Okay, give me a second. Okay, how is it right now? Okay, so we were talking about the advanced Bell stage. In advanced Bell stage, what we have is total shape of the tooth. Okay, you know what, this time I have this kind of a headphone wherein the mic is hanging down, so probably when it touches something, it may create a noise. I'm sorry about this. I'll be getting my new headphone probably in a day or two. So, we'll not have this issue anymore. It's already shipped. Okay? Okay, I'll try not to move a lot. Yeah. Then, now let's talk about, let's go ahead with the slides, and in meanwhile I'll give you a bit of information about the stellate reticulum and the stratum intermedium. In bud stages, there are not many changes in the shape and function, while in cap stage we see this ectomesenchymal condensation, and also the dental papilla and dental sac can be differentiated in the cap stage itself. Papilla, the inner part of the condensation is responsible for the formation of pulp and dentin, while the outer part that surrounds the enamel organ, that is responsible for formation of cementum and pedium. Enamel knot, enamel cord, enamel niche. We had been talking about enamel niche is an apparent structure in the histologic section created because the dental lamina is a sheet rather than a single strand, and often it appears as a concavity filled with a connective tissue. Hopefully that makes enamel niche, enamel knot and cord clear. Then we had been talking about the Bell stage. It is where the tooth crown assumes its final shape. So this is the stage of morphogenesis, and this is also the stage of histodifferentiation, where your inner enamel epithelium differentiates into ameloblast and your outer enamel, and also you have the inner cells forming the dental papilla cells forming the odontoblast. Then you have the cervical loop region and the zone of reflection. I'll be talking about this a bit later. Okay, let's come back to this diagram. With this diagram, we'll discuss the various cells. Okay, in this diagram, you can very well notice these are the inner enamel epithelium. This inner enamel epithelium later differentiates into ameloblast. When it differentiates into ameloblast, for the formation of enamel, there is a process that is called as reciprocal induction that comes into picture. Let's come back to the blackboard. In the blackboard, do you notice these are our inner enamel epithelial cells, right? Are you there with me? These inner enamel epithelial cells, they have an ability to induce the underlying connective tissue cells to differentiate into odontoblast. So what they do is, they tell these underlying cells, that is the dental papilla cells, to form odontoblast. So what you have is, these dental papilla cells, they come here and they start forming a layer of cells that is called as odontoblast. Is it okay? So what exactly happens is, First you have your inner enamel epithelial cells. These inner enamel epithelial cells, they start growing in size, but they have not yet become complete ameloblast. They are just growing in size and they are differentiating. They have not yet differentiated. In the process of their differentiation, they induce the underlying cells to form odontoblasts. Okay, now the odontoblasts are formed. These odontoblasts, they'll start depositing a layer of predentin over here. So you have this new layer of dentin depositing over here. Once the layer of dentin is deposited, one very important phenomenon takes place. That phenomenon is called as cutting of the blood supply to the enamel organ. Do you all feel that this enamel organ, these cells, this all group of cells, this enamel organ is receiving its blood supply from dental papilla? Do you see that? Yeah. Since it is receiving this blood supply from here, deposition of dentin, which is a hard tissue structure, will result in cutting down of the blood supply, isn't it? Because of this cutting down, what happens now? What happens now is this outer epithelium, this outer epithelial layer, it becomes scalloped. So this outer epithelium layer, now what happens is it becomes scalloped. Because of the scalloping, the dental sac connective tissue comes a bit closer to the ameloblast so that it can provide nutrition from this side. Does it make this point clear? All of you? Yes, perfect. Now, one more thing is, till your outer enamel epithelium is collapsing, till it is collapsing to bring the blood supply closer to the ameloblast, till that time you need a certain more of nutrition, till that time to sustain. This nutrition during that phase is provided by your stellate reticulum cells. Do you remember the stellate reticulum cells at this moment? They are the cells between these red colored cells which we had been drawing. Now, very important property of these red colored cells, that is the stellate reticulum, is that these cells, they produce an extracellular material that has a property of pulling in the water. So these, let's draw these red cells outside. Let me draw them red. Okay, these are those red cells which were first the squamous cells. These are the red cells of this region. I am just enlarging it. Okay, these cells, they produce an extracellular material which I have drawn in yellow over there. This extracellular material pulls in a lot of water. It's a hydrophilic material. Since it pulls in a lot of water, that water accumulates in here between the cells, because of which the cells are pushed apart. But cells are attached to each other by tight junctions that are called as desmosomes, and these desmosomes do not allow the cells to separate. So what happens? Because of which what happens is the cells, they are being pulled apart, but they do not actually tear off. They just remain attached at the zone of desmosomes, something like this. Yeah, they assume a star shape because they are attached here. In these yellow zones, they are still attached. And because of the water, they are pulled apart. So because of which they assume this star shape. That is why they are called as stellate reticulum. Okay, does that make this point clear about the stellate reticulum? Okay, so that was about our stellate reticulum, and we were right now, I'm sorry to miss the sequence, I'll actually summarize the sequence for you at the end, but be with me, it's difficult when to talk about which thing to. We were talking about the collapsing of the outer enamel epithelium, right? Can we come back to the same thing again, this diagram again? We had been talking about the collapsing here. Okay, and at this point, if we remember, our odontoblast had deposited pre-dentin. And what was the stage of our ameloblast? They had grown into size, they were differentiating, but till now they had not become fully differentiated ameloblast. Now what this pre-dentin does? This pre-dentin again influences the ameloblast to differentiate further, and this further differentiates, make them become, yes, all this is happening in advanced Bell stage. This induction from the pre-dentin makes the ameloblast to differentiate into, makes the inner enamel epithelium to differentiate into full ameloblast, and now these ameloblasts, they start depositing enamel. So let's have enamel over here. Let's have it in white color. So just, oh, it's not taking white. 1 second. Yeah. Just here adjacent to your pink color, do you see this white deposit? That is nothing but your enamel matrix. Okay. So can you imagine which side your dentin is depositing and which side your enamel is depositing? This point that your ameloblast caused the differentiation of odontoblast, and your odontoblast deposited a pre-dentin that caused further differentiation of ameloblast. This process is called as reciprocal induction. This is a very important MCQ. Okay? Does that make it clear? Now when we had been talking about reciprocal induction, one more thing, just tell me one thing. What started differentiating first? What started histodifferentiation first? Was it ameloblast or odontoblast? I'm not talking about what deposited first. Please understand my question. What started differentiating first was your ameloblast. What completed differentiation first was your odontoblast. Are you getting me what I'm telling you? Although your ameloblast started differentiating first, but they could not complete the differentiation before pre-dentin. But your odontoblast could continue, yes, first pre-dentin, then enamel. When we talk about the hard tissue deposition, it's first the dentin, then the enamel. Okay? If the sequence is clear, you should be able to understand the question and accordingly answer. Please don't mug up the dentin first, enamel later. Understand the sequence, understand the reciprocal induction. Okay? So with this information, we go ahead, we need to learn one more structure over here that is called as membrana preformativa. Now, this membrana preformativa is nothing but a junction of your ameloblast. I don't know. Remember, your ameloblast made the formation of, let me just draw it. This was your ameloblast. Not exactly ameloblast. Let's call them inner enamel epithelium right now. This inner enamel epithelium, it made the odontoblast to differentiate. Before the odontoblast could deposit the dentin, there was a membrane that was intervening between these two layers, that is between ameloblast, between inner enamel epithelium and between odontoblast. This membrane is nothing but your future DJ. Future DJ, isn't it? This future DJ, which is right now just a membrane, is called as membrana preformativa. It's preformativa, not performativa. Okay? Let's go back to our slides. Let's see how much are we able to understand. So we had been talking about the stellate reticulum. Stellate reticulums are the cells between inner enamel epithelium and outer enamel epithelium that produces excess of glycosaminoglycans that are the hydrophilic. Thus they pull in the water, separate the cells. The function of stellate reticulum was cushioning and nutrition. Remember the nutrition that was, yes Priyanshu, all of this is in advanced bell stage. Remember the nutrition that was needed until your outer enamel epithelium collapsed, that nutrition is provided by your stellate reticulum. Then you have dental sac. Dental sac was a condensation of the connective tissue that surrounded the enamel organ, and that surrounding gave rise to the cementum and perineum. We'll be talking about that development a little bit later. Then we had stratum intermedium. Stratum intermedium is this, this green colored layer which I had been drawing. These are the flattened squamous cells that lie very adjacent to these cells. What are these cells? Yes, inner enamel epithelium. These stratum intermedium, they have a very important function. They are very important for the formation of enamel because they have some kind of an important enzymatic activity, that is the activity of alkaline phosphatase and calcium ATPase. A very important MCQ over here. Okay, then we have inner enamel epithelium. We already know it develops into ameloblast and the enamel forming cells. Dental papilla give rise to pulp and dentin. Now outer enamel epithelium and inner enamel epithelium, they proliferate to form Hertwig's epithelial root sheath. We'll be talking about this now. Yes. Okay, before we go to the root formation, let's cover up these few points which we have there in the slides. In the absence of epithelial cells, we are talking about the inner enamel epithelium, no dentin can develop. Why no dentin can develop? Because there would be no induction for the formation of dentin. So by chance, if in some region you have that inner enamel epithelium degenerated, you can just make a note of it. It's there in notes, all these charts are from the notes itself. When we come to making a PowerPoint, what we do is we keep adding certain extra information in here. And if you just happen to see your keynotes, they are provided with a column on your right hand side. What we expect is you should have your keynotes along with you, and rather it would be great if you could just read your keynotes once before you attend the class. Purposely these keynotes have been made precise, they are condensed in, so that you don't have a scary book in your hand which makes it really cumbersome many a times. We need to concise ourselves so that we can go, these are the proteins which we'll be talking about when we talk amelogenesis. Let's not go to that part right now. We'll be giving this information in detailing out. They are the enamel proteins. What I want to cover up today is the basic development of the tooth and the structure of all the things. But I don't know I'll be able to touch upon the structures or not. It seems to be taking a bit more of time. Let's go a bit faster right now. Anytime if you feel me unclear, just ping me up. I'll just halt in there. Okay. We had been talking about the inner enamel epithelium needed for the dentin formation. If there is no inner enamel epithelial cells, there would no dentin. Now, if you just happen to see the diagrams, which is the area, if this was your enamel organ, which is the area wherein the first dentin will be forming? It is at cusp tips. These are the areas where you will see the first dentin formation, cusp tips, and then it proceeds the dentin and the first enamel form. Reciprocal induction we have already seen. We'll go ahead with that. There are some statistics over here. Please make a note of this. We have 42 to 48 days your dental lamina formation takes place. 55 to 56 stage you have the bud stage. Yes, it's 6 weeks your tooth formation starts, you can say. It's approximately that. 14th week, the bud stage for deciduous teeth and permanent teeth. 18th week, dentin and functional aminoblast in the deciduous, and 32nd week. You know, these are the direct text, mug-up part. Okay, so there's hardly anything for me to explain you out here. Make a note of these points. I'm not sure about that being given in keynotes. Take a snapshot of this slide. I'll just hold on. Okay, taking a snapshot is very easy. What you can do is press function and press print screen. You have a button that says print screen, PRTSC. All of you in your system, it's somewhere in the upper right corner. Once you press this, you can open anything, you know, a Word or a Paint, and just do Control V over there. You will have this same screen in your okay, and then you can copy it later. I'm just telling the function print screen. That is nothing but taking a snapshot of your screen, computer screen. All of you clear with this, with that print screen function? Okay, you know, the issue is that we, you know, being in a medical profession, not still very comfortable with computers as such. It's just a small thing. It's just taking the snapshot of the system, the screen what you have. You want to just, you don't have to take it from mobile camera. It's very simple. You know, there is a key in your computer, in your keyboard. There is a key that says print screen. In my computer, it says as PRTSC. It's a common button which is, you know, if you have the insert button. Did everybody got it? Yes, insert and print screen. Perfect. Yes, the same button. What you have to do is, you know, when your screen is open, your window is open, right? What you have to just press function key and simultaneously press print screen. Once you have done that, that copies this picture. Then you open another Word document, or you can open a Paint. I know teaching dentistry is easier than teaching computers, especially online, because I'm not able to show you my keyboard. Actually, I can show you my keyboard also. Do one thing. Yeah, I will do it later, you know. Till that time we would have actually copied this thing. Let's go ahead with this. I'll show you the slide later. Okay, let's come back to the root formation. We had been talking about our enamel and dentin formation, right? So this was our enamel, here the odontoblast, and we had in between the dentin and enamel formation taking place over here. Now what happens is this zone starts proliferating further. How it happens is, not all the cells. We had 4 layers of cells here, 4 layers of cells. That is inner enamel, outer enamel, stratum intermedium and stellate reticulum. But only the inner and outer enamel grows this way. This is called as Hertwig epithelial root sheath. Okay. Now what happens is, if you take the tooth, before it grows downwards, it actually bends inside like this. This was your tooth germ, enamel organ. When your Hertwig's epithelial root sheath grows, it actually bends inwards first, this way. Okay? If this is your tooth enamel organ, it bends inwards. Okay? That is the diaphragm that is created. That's the total diaphragm that is created. Then it is in this zone the growth of Hertwig's epithelial root sheath takes place. Are you getting me? Yeah, this is the area of CJ that gives the constriction to the crown before the formation of the root. So this is your epithelial diaphragm, and just at this area your Hertwig's epithelial root sheath continues to grow. So now you can imagine, if this area continues to grow, what will happen is your diaphragm will be shifted down, isn't it? Is it clear? Yeah. So what happens is, this area continues to grow, so your diaphragm is shifted down like this. So the growth zone is not exactly the end, it is this zone where it grows. This is how your Hertwig's epithelial root sheath grows. So we can see it here in this diagram. Here, other than the 4 layers, only the outer and the inner layer grows. And at the cervical region itself, it bends inwards. Do you see the bending inwards of it? This bending inwards is nothing but the epithelial diaphragm. And now in this area, the proliferation continues. Yes, it's like a leg and a foot, you can say. The foot remains in the place and leg keeps growing. So your leg keeps growing over here and your foot keeps on going down. And we already know one of the very important property of inner enamel epithelium, that it can differentiate the dental papilla cells into odontoblast. Okay, so we now know that the inner enamel epithelium can make odontoblast. So even here you have inner enamel epithelium that is bringing on the influence on the inner cells, the dental papilla cells, to form the odontoblast. So now you have the odontoblast forming in here, and these odontoblasts deposit the layer of dentin. Is that clear? The formation of root dentin, is it clear? Once the root dentin is formed, now you see root dentin forming over here. Once the root dentin is formed, your Hertwig's epithelial root sheath has completed its main function of having the odontoblast differentiated. So now it starts dissolving. Do you see the dissolution over here? This dissolution makes it possible for the outside mesenchyme to come in contact with the dentin. What was the outside mesenchyme called as? What was the mesenchymal condensation surrounding the enamel organ called as? Dental sac. Yes, now the dental sac comes in contact with the newly formed dentin, and this newly formed dentin causes the dental sac to differentiate into the cementum forming cells, that is cementoblasts. Yes. So now what happens is, you have the cementoblast coming and settling over this, and they deposit cementum. So enamel is forming, cementum is forming. While the cementum is formed, during that time itself, the fibroblasts of this region, they start forming the periodontal ligament fibers, the collagen fibers that gets incorporated in the cementum. So your cementum and PDL are nearly forming simultaneously. Does that make it clear? Yep. So here you see it again, right? These are your epithelial diaphragms, and this is your formation of the dentin, and this is the simultaneous dissolution of Hertwig's epithelial root sheath and formation of cementum and PDL. Easy, right? Now let's see the anomalies associated with it. To have the dentin on the root, what do we need? Yeah, we'll be talking about the multi-rooted teeth. Let's just complete this Hertwig's part. Yes, it's after the dissolution of Hertwig's epithelial root sheath, the cementum forms. After the dissolution, it is possible for cementoblast to form. If it doesn't dissolve, the cementum will not form. Yes, odontoblast will stimulate cementogenesis. Okay, let's go ahead. Can you imagine a scenario if your Hertwig's epithelial root sheath, you have your long Hertwig's epithelial root sheath. This was your diaphragm. Imagine a scenario that your Hertwig's epithelial root sheath is damaged before, in this region supposedly, it's damaged before the dentin could form. What will happen? A small zone. If you have the imagination, actually, what I am drawing is a two-dimensional diagram, but what actually happening is the whole tube of the Hertwig's epithelium is going down. Okay. Now this whole tube, in the whole tube, if there is one area wherein your Hertwig's epithelium is lost totally before even the dentin is formed, so what do you see? No cementum. Okay, no cementum. Do you see the dentin? Do you see the dentin? No dentin. Yes. So no dentin, then no cementum. Yes, it would result in the formation of accessory canal. Is it clear? Yes. Now imagine a scenario. Now I give you a second scenario. Be with me. Imagine a scenario wherein the dentin is formed and your Hertwig's epithelial root sheath fails to dissolve. It doesn't dissolve. What happens? No cementum. Yes. No cementum, and this typically happens in the region of the neck of the tooth. This typically happens in the region of cervical areas, right? And one more thing, till now what we are talking is Hertwig's epithelial root sheath did not dissolve. Now imagine a scenario, this Hertwig epithelial root sheath also has inner enamel epithelial cells, isn't it? And these are the same inner enamel epithelial cells which had formed enamel in the crown. Imagine if your Hertwig's epithelial root sheath, inner enamel epithelium differentiate into ameloblast, they will result in the formation of enamel pearls. Perfect. So you people are very oriented. I don't think so even I have to complete my question before I get the answers. Nice to see that. Yeah. Okay, so you have the three scenarios. This is the second one wherein you have that Hertwig's epithelial root sheath attached. You have the exposed dentin. Yeah, now we'll be talking about multi-rooted teeth. In multi-rooted teeth, this is the visualization of the tooth germ. This was your enamel organ. You just hold it and see from down. Right? That is the view which we can see over here. See it from the down, from the direction of the root. Okay? So this was your Hertwig's epithelial root sheath growing in single rooted teeth. In multi-rooted teeth, what you may have is these tongue-like projections that come and join with each other, dividing your single root into two roots. So how many tongue-like projection do you need to form two roots? You can see in this diagram. How many tongue-like projection do you need to form two roots? Two. How many do you need to form three roots? Three. Okay? Yes, perfect. Hopefully that makes it clear. So because of this, what happens in between, you get an epithelial island kind of a thing that helps in the formation of furcation area. Once the Hertwig's epithelial root sheath, makes dentin, it starts dissolving. The remnants of the Hertwig's epithelial root sheath, they are called as cell rest of Mallosis, and these are the ones responsible for the formation of periodontal cyst. And one more very important point about these epithelial cell rests is they have a very typical property of moving occlusally as the person ages. Okay, so if you happen to take the histologic section according to the age, you will find more of an epithelial cell rest in the cornal region in aged people as compared to the young people, because these cells, they have tendency to move upwards. The diagram of enamel pearl, you already know what it is. Let's talk about eruption now. Is the things clear? Are the things clear? Are you able to imagine the whole process in one go? What were the enzymes that stratum intermedium was associated with? What were the enzymes of stratum intermedium? Oops, no answers. Alkaline phosphatase and okay, let's talk about the eruption now. In eruption, we had already seen about the dental lamina and the successional lamina. Successional lamina is the one that gives rise to the permanent teeth, and distal lamina was the one that is the distal extension of the dental lamina to form those permanent teeth which did not have the predecessors. We all know that point, and with this information we have some more information which we can notice in this diagram. If you notice, your permanent tooth bud actually forms lingual to your deciduous. Do you see the primary here? Yeah, it's lingually. Ultimately your deciduous erupts. Since the deciduous erupts, the position of your permanent becomes lingual and apical to the deciduous. Is it okay? It becomes lingual and apical to the deciduous teeth. Now what happens is, initially when a permanent tooth bud was forming, it develops in the same crypt wherein your deciduous tooth was present. Same crypt, same place. Once your deciduous start erupting, this crypt, there is deposition of the bone over here that separates the crypts of the deciduous and permanent. But this separation is not complete. You have a small opening that remains. The small opening that remains between your deciduous and permanent, this opening is called as gubernacular canal. Gubernacular canal. Now this gubernacular canal is filled with the epithelial cells. These epithelial cells make gubernacular cord. This cord is very important because it makes a pathway for the eruption of the permanent teeth. It gives a path from where the permanent teeth has to erupt. And the second important thing that happens because of this cord is, since this cord is accumulation of the epithelial cells which do not have the direct blood supply, during the eruption of the permanent tooth that follows this cord, what happens is there is no bleeding seen. Even when the deciduous root is resorbing, it's shedding and the permanent is erupting, all this process happens through a predefined path. That is why we do not see any bleeding as such, any obvious bleeding during shedding and eruption. This diagram just gives you an idea what are the zones. We'll be talking about it, don't worry. What, Naren? I'm not getting from gubernacular cord. Do you want to say something? Naren, you have any doubts? Yeah, you basically your deciduous and permanent, they develop in same crypt. Then there is deposition of bone here, and this deposition is not complete. There is an opening layer that is called as gubernacular canal, and in the canal you have the cells that filled in, epithelial cells that make up a cord like structure, and that is called as gubernacular cord. And through this cord your permanent teeth gets a path to erupt. No voice? Others? Are you able to hear me? Is it breaking or something? Do you want me to refresh my window? Tell me. Okay, let me just refresh it anyways. It will take a second. Hi all of you, are you able to hear me now? Okay. Okay, we had been talking about the various stages and all that. Our first thing was initiation of the tooth bud, that is stage of dental lamina initiation. This stage, if there is any defect, what will happen is there will be failure of initiation result in enodontia. If there is abnormal initiation, it will result in supernumerary, fused tooth or geminated tooth. Hopefully you know all these terms, supernumerary, fused and geminated. We have already seen it in OPAT. Then you have MCAP stage, you have proliferation. In early bell stage to late bell stage, you have histodifferentiation and morphodifferentiation. Histodifferentiation, if there is any defect, you will see result in the form of dentinogenesis imperfecta, atypical dentin. If there is any defect in morphodifferentiation, that will result in abnormal size and shape of the teeth. Right? If there is any defect, particularly in any matrix, be it enamel matrix, dentin matrix, then you see enamel hypoplasia, hypocalcification, hypomineralization and all those things. This chart is a very important source of MCQ. Actually, this chart is from Orbals. Okay, with this, if you have both the choice of histodifferentiation and morphodifferentiation, if you have an MCQ having both advanced and early bell stage, go in for advanced bell stage, because it is there we have the histodifferentiation and morphodifferentiation complete. But it begins in early bell stage. It starts. Okay. Now we have certain more things which I'll be touching upon in the next class. I want you all to be clear with these points before I go to those detailing. This would be about some of the genetic codes. I think so Dr. Bhavna would have at least told you about some genes which are responsible for tooth formation. I'm not sure if she has. Homeobox genes and all those things. Yeah, Tata box, homeobox. Okay, that's great. So these are few points which I'm not touching upon in today's class. And secondly, we'll be talking about some of the applied aspects, especially about some of the enamel matrix derivatives, which actually comes in perio. Rather, I will be touching upon those points in perio also. Right? These are actually the products of Hertwig's epithelial root sheaths and all those. That's why I'm not going into the details right now. You know, when we go ahead with the preparation of entrance and covering the theory part, we have a lot of limitations as far as time is concerned. So many a times we may have to restrict, and what we do is detailing out is very easy when we go with the back reference. That helps us to stick to the point. So our purpose is, let's go ahead with the basic, then we go with the MCQs and we back refer to cover up the remaining points, and our discussion sessions will help us in, you know, extra point coverage. Hopefully that will, you know, help us cover more in less time. Okay, now be with me, you know, right now we are progressing into a bit of a mugging up zone. So be with me, after every 2-3 slides we'll just have a recap questions, you can say. So let's start with Dentin. Dentin is light yellow, it gets darker with age, and you have 35% organic and 65% inorganic. Very important. Inorganic crystals here are plate shaped and they are smaller than hydroxyapatite of enamel. This is the point which probably you would not have known before, so just make a note of this. These are smaller than hydroxyapatite crystals of enamel. The main organic content is your type 1 collagen. Now this picture gives you idea of how your dentin. Do you remember how your dentin was actually forming? Is you have your let me go to the whiteboard over there, blackboard. Let me draw a bigger version of odontoblasts. These were your odontoblasts. These odontoblasts differentiated, and later when they deposited pre-dentin and they start moving away, they move in which direction? They move in the direction of pulp. So your dentin is deposited from DJ towards the pulp. Is it clear? Now during this deposition, during the movement of the odontoblast from DJ towards the pulp, what happens is this odontoblast leaves a process of it inside the already deposited dentin. So as it keeps growing, no, this is not Thom's process. It is the odontoblastic process that it leaves. So, you know, more it grows, more it goes towards the pulp, the longer the odontoblastic process becomes. Okay? So this is how the odontoblastic process is left inside the dentin, and because of the presence of this odontoblastic process inside the dentin, dentin has a typical tubular structure. Okay? Now one more point that you have to note is, since the odontoblast and, you know, all these things are moving inwards, if you just remember your enamel organ, you know, these odontoblasts are moving inside. Anything that moves inside will have less space, isn't it? Imagine a sphere, you know, if you're moving inside, the circumference keeps on decreasing. So there is less space for odontoblast. So what happens is, this odontoblast, they start crowding up. And because of this crowding, initially they were going in a straighter direction. Later, because of the crowding, they assume their odontoblastic processes, they typically make this bend-like thing that gives a typical S shape to the what is that called as? Odontoblastic canal. I'm just not getting the term. Tubules, dentinal tubules. Is it clear? What is happening is, your odontoblast is moving inwards from DJ towards the pulp. While moving inwards, it is leaving behind the odontoblastic process. This odontoblastic process occupies an empty part inside the total dentinal structure. This empty part is called as dentinal tubules. These dentinal tubules, they assume a typical S shape because of the crowding of the odontoblast that takes place when it moves inwards. These 2-3 points are very important, and they are the only ones needed for you to actually solve the questions on dentinogenesis. Is that clear? Does it make it clear? Yep. Okay, so herein you can see these are the odontoblasts. Do you see these odontoblasts? These are the odontoblastic processes, right? Just odontoblastic processes, they are contained in the dentinal tubules. Adjacent to the dentinal tubules is the peritubular dentin. Here in the mineralized zone, and this is the non-mineralized zone, because first you have the unmineralized dentin deposited that gets mineralized, then you have the next layer of the unmineralized dentin deposited, and then you have the mineralized dentin. So with this process, can you tell me, if you take a section of a developing tooth, which side will you have predentin? Will it be pulpwards or will it be towards the DEJ? It would be still a confusion. Still a confusion. See, what I'm telling is, this was your DEJ. This was your DEJ. First thing that odontoblast deposit is predentin. Okay? So they deposited predentin. This is the yellow colored predentin. Now this predentin gets mineralized. Once it gets mineralized, it becomes what it becomes? Dentin, matured dentin, correct? Then odontoblast, they move away. Once they move away, they deposit one more layer of dentin, that one more layer of predentin over here, right? Then again the mineralization takes place, correct? Then again the predentin is deposited. Which side is predentin now? Pulp side or DEJ? Soumya, still DEJ? Your DEJ is left here. We are moving pulpwards. We are moving towards the pulp. So always your new layer will be deposited towards the pulp. So your predentin will be towards the pulp. Is that clear? It's clear, right? It's okay if you make a mistake in answering, but at least if it's clear, I'll go ahead. Okay? Don't get confused on that. Imagine the process. Okay, now based on the time of process, you have predentin. Why I was talking about predentin? Because you have to actually separate the term predentin from other classification. Okay, term predentin is the first form dentin and it is not mineralized. That is approximately 2 to 6 micrometer. Primary dentin is the first form dentin, the dentin that is before tooth eruption. Now, do I confuse you when I say predentin as first form dentin? And again I say primary dentin is a first form dentin. How is that? What you have to understand is dentin is getting deposited in layers. Then you take a whole mature tooth and section it. I'm sorry. Okay. Is it okay now? I'll not move. Yeah. When you take tooth and section it, you have the layers of dentin over there. Among these layers, some of the layers are the older layers which were deposited first, and some of the layers are newer layers. Based on that classification, you have primary dentin and secondary dentin. Primary dentin is the dentin that was deposited before the tooth, before the root formation, right, before the tooth eruption rather. While secondary dentin is the dentin formed after the root completion. Okay, based on that it is classified into primary and secondary. Primary dentin again has two layers, the mantle dentin and the circumpulpal dentin. Mantle is the first layer, that is 20 mm thick, and the circumpulpal is the remaining primary dentin. Now hopefully you don't confuse your predentin with any of these layers, because predentin comes into the picture during the deposition of dentin, not after the dentin is formed. Does that make it clear? All of you? Okay. Next we have the incremental lines of dentin. As we already know that dentin deposits is an increment, and the incremental lines of dentin are von Ebner's or the lines of imbrication, and the distance between these lines is 4 to 8 micrometer. And at some regions, due to some disturbances, these lines could be accentuated, and these accentuated lines are called as contour line of Owen. Okay, let's come back to the structure. We had been talking about the dentinal tubules. The dentin that surrounds this tubule is called as the peritubular dentin, and it is more mineralized than the other dentin. Okay, so if you just take it in a cross section, my whiteboard is all full. I don't know if I can just draw more. Okay, I'll take another blackboard. If you take in cross section, these are your dentinal tubules. Inside that you have the odontoblastic processes. Surrounding these dentinal tubules, you have the dentin that is called as peritubular dentin. This orange colored is your peritubular dentin. In between the peritubular dentin, what you have is this area is your, what is this? Which type of dentin is this? Pink colored. Intertubular dentin. So what we know from our discussion is your peritubular dentin is more mineralized than intertubular dentin. Intertubular dentin forms the main body of the dentin, as we can very well see in this diagram, right? Now we have interglobular dentin. To understand interglobular dentin, what you have to understand is the mineralization process. Now we have seen that the dentin is deposited in the form of predentin. Okay, so let me just draw a predentin for you. I am drawing it in a flat surface. You can say this is the whole surface and this is the predentin. Just not to confuse you, this was our DEJ and this was where predentin got deposited. Okay, if I view it from this side, inside, it would look something like this, a total surface of predentin. Are you all there? Do you understand what I am drawing? Yeah. Now when this predentin starts getting mineralized, this mineralization takes place in a kind of globular pattern. You know, there are globules of mineralization that takes place. It happens in this way. Okay, So when the mineralization takes place, it happens in a kind of globular pattern. Are you able to get these globules? Do you want me to draw in some other contrast colors? These are the globules. Okay. Do you imagine when these globules meet each other, there is a possibility of these triangular zones. Do you notice these triangular zones? You know, there is a possibility that these triangular zones, which are not overlapped by these globules, they remain less calcified. This is nothing but your interglobular dentin. Do you understand your interglobular dentin? This is other than the normal. You know, among this whole structure, whole predentin, you will be having your peritubular, intertubular, all those dentin. What I am talking about is the total sweep of mineralization that takes place in the whole dentin. It happens in a globular pattern, and in between some of the zones, the triangular zones remain less calcified. These are your interglobular dentin. Okay. So hopefully that makes you understand this point. Globules of mineralization fails to fuse, present in the crowns of teeth in the circumpulpal dentin just below the mantle dentin. This is the main zone where you can see the interglobular dentin. A very important MCQ point. A very important MCQ point. Please make a note of it. Okay. Now we, if you remember the diagram, where was it? Yeah, if you remember this diagram, what happens is these dentinal tubules, you know, if you see these dentinal tubules, at somewhere at the end where they are very close to the DEJ or CJ, at that particular region they branch and they loop and they divide. This looping, dividing and branching results in formation of the granular layer of tomes. Do you understand now what is granular layer of tomes? And this granular layer of tomes is more prominent in the areas of root which is very adjacent to cementum. Does it make it clear? Are you all there with me? Is it clear to all of you? Okay, then we have the odontoblastic process. Actually, these odontoblasts, they, as we have seen, they have been moving, yes, they have been moving away from the if you see this diagram, you know, these are the odontoblasts which are moving away and they are leaving behind the odontoblastic process. So now if this is the DEJ, if this is DEJ, some of the odontoblastic process may actually go beyond the DEJ and extend into enamel. These processes, these odontoblastic processes that extend into enamel are the spindle fibers. They are the spindle fibers, the enamel spindles. Oh, so sorry. They are the enamel spindles. Okay. When we say enamel spindles, you know, one very important thing about enamel spindles is, if somebody asks you which is the only organized structure, which is the only organic structure present in enamel, that is the enamel spindles. They are the organic structure. Typical one having a lot of organic content is enamel spindle, and actually they are not the part of enamel, they are rather the continuation of dentin into the enamel. Okay. If we'll be talking about lamella and other things in enamel, all these lamella, you're talking about being organic? Lamella, yeah, they can have organic content in them. But when we talk about, I'm sorry, the question actually would be framed as the only mesenchymal portion of the enamel. Which of the following enamel part is derived from mesenchyme? If you just notice, if you have noticed in the tooth development, what happens is your dentin, your cementum and pulp, all these parts are derived from the mesenchymal condensation. So they are the mesenchymal derivatives. But your enamel itself is derived from the inner enamel epithelium. That was your ectodermal derivative. So only enamel is the ectodermal derivative. So in the whole enamel structure, your enamel spindle is the one that is a mesenchymal derivative. Okay, does it make it clear? Yeah. So when we talk about the dentin formation, we have some of the points over there. In this point, what we already know how the dentin forms by the movement of odontoblast and by the differentiation in the movement of odontoblast. The first sign of the dentin formation is the appearance of large diameter collagen fibers. They are called as von Korff fibers. This is MCQ. These von Korff fibers are the type 3 collagen fibers. Okay. Now, as the odontoblasts, they form their odontoblastic processes. They also form the small membrane-bound vesicles that are called as matrix vesicles. And these matrix vesicles are the site of initial mineralization. So, how it happens is the organic content that is formed, it has the first appearance of the type 3 collagen fibers, which are von Korff's fibers. Other than that, you have the matrix vesicles. These matrix vesicles are the site of primary mineralization. When we talk about the mineralization, already we had been talking about the pattern of mineralization, that is a globular pattern. If you remember, we had been talking about the interglobular dentin that happens because of the globular pattern of mineralization. There is one more pattern of mineralization, that is a linear pattern wherein it's mineralization sweeps in layers linearly. Okay, and this pattern is more uniform and the rate of formation is low. The globular pattern is typically seen in mantle dentin. Right? All this clear? Okay. Next, when we had been talking about the dentinal tubules, we saw that dentinal tubules, they have a typical S-shaped because of the crowding. Now this S-shaped is a gentle curve, and type of globular pattern of mineralization actually starts in the mantle dentin. Your circumpulpal dentin is just adjacent to your mantle dentin. So this pattern actually sweeps in from the mantle dentin to the circumpulpal dentin, but it is in the circumpulpal dentin that you have more of the areas, unmineralized areas left between this globular thing. Phosphorylene, probably I'm not very clear with that point, Priyanshu. I may have to just get back and refer back and come back to you, rather than just answering it vague. See, Prasad, don't confuse. Interglobular dentin is an effect of globular pattern of mineralization. Because of that globular pattern of mineralization, we may have those triangular areas remaining, uncalcified. That form the interglobular dentin. So globular pattern is a pattern of mineralization, and interglobular dentin is something that results because of those globules not fusing up. Okay? Yep. So we have this pattern of mineralization more in the mantle circumpurple dentine. In the circumpurple dentine, we have more of interglobular dentine remaining. All these sentences are actually direct copy paste from 10K. So yeah. Okay, we have been talking about the convexity of the dentinal tubule. The first convexity faces towards the root tip. Okay. And there's one more thing, the ratio of the dentinal tubule per unit area on the pulpal and the outer surface of the dentine is 4:1. That means on the pulpal side they are more, which side are they more crowded according to this ratio? What do you understand? Are you able to imagine this point? Which side they are more crowded? Yes, the ratio is more on the pulpal side. That means they are more crowded on the pulpal side. Okay. Further, they are also larger in diameter near the pulpal cavity. They are 3 to 4 micrometers. Near the pulpal surface of the dentine, the ratio is 50,000 to 90,000 per square millimeter. All these values are important source of MCQs. There are more tubules per unit area in the crown than in the root. Okay. 4:1, this value. Do you remember what was the thickness of the layers of dentine formed? What was the lines of incremental line of dentine called as? Four to 8. Yes. Let's go ahead and see some of the dentine that is associated with the 8 changes. In that you have the dead tracts. Now what happens if you remember, your dentinal tubules always fill into the are filled in by the dentinal odontoblastic processes. In some of the situation wherein there is damage to the dentine, there is damage to the odontoblastic processes, you may have these dentinal tubules empty, and whenever they are empty they appear dark in transmitted light and they appear white in reflected light. Okay. One more thing I want you to answer me now is the microscope which we have been using to see the slide in our oral pathology, oral histology classes. What was that slide? Did we see it in transmitted or did we see in reflected light? Okay, this was our microscope. I am sorry for the bad diagram over there, but what I want is just the representation. This was where we saw it from. Okay, this is our slide in here. Okay, this was a reflecting mirror over there and this was the slide. Right? Some of you are saying the reflected light, rather most of you are saying the reflected light. So that is why I want you to be clear. Do you remember seeing the dead tracks? Dead tracks in your DH class? Which color you saw the dead tracks? Which color? What was the color which you saw the dead tracks? Yeah, even I feel they were black, but that means the slide is wrong, isn't it? What does this slide say? That they appear white in reflected light. But we saw it black. Confusion. Confusion. Isn't it? Now? Okay, just have a look here. Have a look at this diagram. This was the mirror which we used to reflect the light. But this light is then getting transmitted through the slide. Isn't it getting transmitted through the slide and we are seeing it through the eyepiece. Yeah, so this type of microscope, actually we are seeing our slide under transmitted light. The light is transmitted through the slide. Yep, we call it reflected when actually our light source is coming from here, falling onto the slide and going into the eyepiece. Then it is called the reflected light. Okay, so we have never been seeing in, you know why? I am making this point clear, you know, because today we are seeing this slide over here. We'll just try to mug it up. Okay, black in transmitted light, white in reflected light. When it comes in exams, you will not remember this. What you will remember is, you will remember your microscope and the color of the dead tracks. And you will imagine what kind of light was that. And you will just think, oh, it was a reflected light. And you will make this question wrong. And many of people make this question wrong because of this notion. So just have that point clear. This is just to make you remember the things. Okay. Now let's come to the sclerotic dentin. Transmitted or light in transmitted light and dark in reflected light. Transparent or light in the transmitted light and the dark in reflected light. Okay. So your dead tracks were dark, your sclerotic dentin was transparent. Then you have reparative dentin. Reparative dentin is dentin formed on the pulpal side in response to injury. Actually, you know, this is the problem which I faced during my preparation. I'm not very sure which microscope uses reflected light, but I think so. We have many refractive kind of, refractive should be the passing through. I'm not very sure which particular microscope uses reflected light. That's a question, you know, we should have. Phase contrast, can't say. I don't think so it uses reflected light. Let's have it as an inquisitive assignment, you can say. We'll not have any questions on that definitely. Yeah. Let's just have, you know, we can just have, for the sake of fun, you can say, we can just have and Google it out and we'll find it out. Okay? Let's go ahead with this right now. Yep. Tertiary dentin. Let's talk about reparative dentin. Let me come back here. We had been talking about primary dentin, secondary dentin. Your primary dentin was the one formed before root formation was complete. Your secondary dentin was the secondary dentin that was formed after the root formation, because the dentin formation is a continuous process, it does not stop. But whenever there is an injury, after an injury, whatever the dentin is formed, that dentin is tertiary dentin or reparative dentin. So tertiary dentin and reparative dentin are interchangeable terms. Is that okay? We have this dentin hypersensitivity. I would actually like to cover this dentin hypersensitivity issue with perio, if it's okay with you all. But with dentin hypersensitivity, what we come to know exactly is that your dentin is a sensitive tissue and you have the nerve supply over there. Now, initially it was considered, there are various theory of dentinal hypersensitivity. The most accepted theory is the fluid dynamic theory, wherein it's the movement of fluid that results in the transmission of impulses in dental hypersensitivity. Dentinal tubule having the fluid in there, whenever there is anything cold, the fluid contracts, you know, creating a pressure zone, causing the stimulation of the nerves. Whenever there is heat, the fluid expands, creating the pressure zone again, causing the fluid is the one that explains the dentinal hypersensitivity best. Okay, next we come to the enamel formation. Priyanshu, I don't think so it's like that. I think so they are same. But if you have come across something like that, let's just get the reference and discuss about it. What are the 2 points? There was one more point about it, Priyanshu, you had told. Let's make a note of this. What was your first question, which I told that I don't know the answer right now? Yeah. So all of you just make a note of these 2 points. What we can do is probably in your reading zone. All of you, do you all have a reading zone now? All of you, do you have a reading place wherein you all are reading? At least one corner, one wall. All of you have a board on there. I mean, at least a thermocol pad or something stuck there. There is an orientation. I am very particular about this board, I bet if somebody, Prasad, you can have one here also. You live in a hostel, right? Please have one board with you all, be it a small board or anything. No procrastinating on this. And what I want you to know is, whenever we come across such controversial points, which rather I make a note on the sticky on my laptop, because I happen to be on the laptop most of the times. But I'm very sure you people are not on the laptop since you're reading from books, isn't it? So have these sticky notes. Yeah, don't look at it, Soumya. I don't say even if you don't look at it, the making of the notes and sticking to it will create an impulse that goes to your brain and makes that thing stay in your mind a little more than by just simple reading. That process itself creates certain links. While you're writing some certain key points, you may not see it ever, but you will remember that I made a note and I had stuck that point there on the keynote. That will itself make you remember the thing. And I really believe in that board. It has been helping me throughout my preparation, always, even during my MDS. I always felt that I'm really bad at remembering names. But when it came to my MDS final exam, it was that whiteboard that made me write. I could write more than 20-25 authors in my every question. And I was surprised myself even after, writing the exam. I was rather surprised, really surprised. From where I could remember those names. It was just on my whiteboard. Okay, so do that, please. I'm just not bluffing it. If some of you must be knowing, there's a student of ours, Dr. Prerna. She got a 3rd rank in KSET this time, and I happened to talk to her. She was like, ma'am, I want you to take to my room, because this time it's not only one wall. I made all the 4 walls full with stickies. And I was so happy to hear that. Unfortunately, I didn't get the time to visit her room, but I was really happy with that. And we have an example right there. So just make it a motivational thing. Have the board right now. Take permission from your parents to have those stickies in your house. Yeah. Let's go ahead. Let's talk about the enamel formation. When we talk about the enamel formation, we'll be talking about ameloblasts here. Now, these ameloblasts, when we talk about the cross section of these ameloblasts, they have these hexagonal kind of a cross section. Now, if you notice in this diagram, do you see these hexagons over here? Okay, these hexagons are the superimposed ameloblasts. Underlying, you see these enamel rods. Enamel rods have a typical keyhole shape. Do you see this enamel rod over there? If you see this head and tail part, the head part is formed by one ameloblast, and the tail part, if you see your tail part, should I highlight it a bit more? This tail part is contributed by 1, 2 and 3 ameloblast. Okay, see what this diagram actually shows you is, for example, this was your ameloblast. You know, this is just a two-dimensional diagram. If you view it from this side or a cross section, what you see is ameloblast, they have a typical hexagonal cross section, and when they are forming the dentinal tubules, when they are depositing it, when they are depositing the enamel rods, these enamel rods have a keyhole kind of a structure. So how it happens is, your one ameloblast contributes to one head and the tails of 3 adjacent enamel rods. Are you getting it now? So the tail is, if you notice here, the tail is formed by 3 ameloblasts. Head is formed by 1 ameloblast. Head is formed by 1 ameloblast. Tail is formed by 3 ameloblast. Right? So one enamel rod is formed by how many ameloblasts? Perfect. That's the answer I am expecting, because that will be the MCQ. There is one more MCQ. Okay? Now you all be with me. There is one more MCQ. Second thing you have to imagine. Now you notice in over here, one ameloblast. Just shift your concentration to one ameloblast. This ameloblast is contributing most to the head of one enamel rod. Other than that, here along the sides, it is contributing to 3 different tails. Should I draw those tails for you? I'll try to, but hopefully I don't mess up with the diagram. This is one tail. This is another tail. And here you have one more tail. Do you see that? So you have this yellow colored ameloblast contributing to one head here, and 1, 2 and 3 tails. So total how many enamel rods it's contributing to? One ameloblast is contributing to how many enamel rods? Okay. One ameloblast is contributing to how many heads of the enamel rods? How many heads? One head. One ameloblast is contributing to how many tails? One tail is contributed by how many ameloblasts? One tail is contributed by how many ameloblasts? Perfect. One head is contributed by how many ameloblasts? Perfect. Hopefully everything clear. See, they are all different statements, you know. If you understand this picture, it would be really easy. You know, I believe in reading with diagrams. I think so everybody would. Okay, let's talk about the characteristic. You have maximum thickness of enamel at the cusp, that is 2 to 2.5. Specific gravity is 2.8. Very important MCQ. I think this is the first MCQ in the pulse. Enamel is semi-permeable. Chemically, it is 96% inorganic and 4% organic. Important. Now we have been talking about the number of dentinal tubules, if you remember. Herein we are talking about the number of enamel rods. Enamel rods, we have 5 million enamel rods in the lower lateral incisor, which is the smallest tooth, and 12 millions in the upper first molar. So the range would be 5 to 12 million. The length of the rod is greater than the thickness of the enamel because of the oblique direction and the wavy course. The rods are not very straight, they are a bit wavy and they are oblique, so they are longer than the thickness of the enamel. Their diameter is 4 micrometer and they have this fish scale, hexagonal, oval or keyhole appearance. Diameter of enamel rod increases from DJ toward the surface of enamel. So at the surface of the enamel, it is more or less. It's more on the surface or less on the surface. Perfect. And what about the dentinal tubule diameter? Towards the pulp, it was more or less? More or less, dentinal tubules. More on pulp, more on pulp. They were more crowded and more thick, more in diameter towards the pulp. Okay, in this diagram you actually see the keyhole structure, which you should be clear of. Now when you see, there are a few more points. This is the cross section. If you cut it in this way, what you see is it will pass through head and tail, head and tail. Because of this, what you notice it is the layers, the rod and interrod substance. But actually, is there any rod and interrod? No. What exactly is rod is nothing but you passing through the head, and what is the interrod is passing through the tail. So it is just a visual phenomenon because of the various cross sections of the enamel. Right? Other than that, what you are supposed to notice is that if you take the head and tail, the head is directed occlusally. Getting confused? See. Okay, let me clarify it. Are you all receptive till now? All of you? Okay, so I have maximum Y, so I'll go ahead with it. See, whenever you have an enamel, if you take a cross section in one direction, you will have this keyhole kind of a pattern. But if you cut it longitudinally, your section will pass through. You can just see this three-dimensionally, here it's passing through the head of one rod and the tail of another rod. Because your rod is not a round rod, in cross section it's having that tail and head. So because of that, in longitudinal section you have an appearance of rod and interrod. Do you understand that now? In this section you will be seeing this rod and the tail part looks like an interrod. It feels like some substance between the two rods, but actually you are cutting the tail of the other rod. Okay, and if you notice inside this, do you notice the prisms over here? See, this is your keyhole. If you notice the prisms over here, these prisms are parallel in the head or the body, but when you go in the tail, they just fan out. They are becoming, they are just getting turned like this. Here they are parallel. Here they are parallel. What? Because crystals are oriented differently in head and tail? What is because of that? I mean, I'm not getting the total question, Soumya. No, rod and interrod, see, it is nothing to do with the crystals. Rod and interrod is simple, just you have a cross section halfway, it's going through the tail and here it's going through the head. That is why it's giving two different things. And yes, tail and head appears different because of the different crystalline structure, you can say that. That is why even the rod and interrod will have the different structure. Yeah, you can say that. Definitely. They have a different appearance because of the different prism arrangement. Now if you see the prism arrangement, you see the fanning out of the prisms here in the tail, and this fanning out is approximately 65 degrees, and this is MCQ. If you talk about the length of the prism, you have 0.5 to 1 micrometers and 30 nanometers thickness. What else? This dimension, 5 micrometer in breadth and 9 in length. Okay, and hopefully this diagram has a lot of information. Occlusal direction means, wait, let me just draw a diagram for you. If you take a cross section here, this is occlusal and this is apical. Do you understand that, Himlata? All this we have covered actually. This thing should be easy. What is the difference in the direction of the enamel rods of deciduous and permanent? Let me just draw it. Tell me which side is deciduous and which side is permanent. Okay, I have, and two people have given option B. My question is, which side was deciduous? And the correct answer is A. This is your, sorry, correct answer is B. This is your deciduous. Why? Because in permanent you have this oblique direction in the apical region, while in deciduous it remains horizontal. Yep. Okay, then we have some more structures. We have gnarled enamel. Let me see. This is the gnarled enamel over here. Do you notice it here? This is the bundles of rods that intertwine irregularly, and that is the gnarled enamel. Then we have Hunter-Schreger's band. Hunter-Schreger's band are the alternate band that originate at DJ. Okay, they are formed by typical optical phenomenon. They originate at DJ, they pass outwards, and they represent the regular changes in the direction, and they also represent the functional adaptation. Then you have the structureless layer of dentin. Oops, my headphones not that comfortable. One second. A whole round. It will just come and end over here, isn't it? this ending, if you see on the surface, now if I just happen to see this tooth from front, what I will see is this kind of pattern, especially in the cervical zones. This is your perikymeta. Okay, see here in if you see the incremental lines here, they end up on the surface, and that gives a typical perikymeta appearance on the surface. Then we have cracks. Cracks are narrow fissure-like structure that are believed to be outer edge of the lamellae. Now, cracks are nothing but you have your enamel, and the cracks extend from the occlusal to inwards. Then you have neonatal line. Neonatal line is an accentuated diagram of perikymeta. This is a diagram of perikymeta. You know, if you see the incremental lines, they just go like this, and you know, at some areas they actually touch the surface here. Do you see them touching the surface? If you imagine your canine, have you ever noticed the canine tooth? You know, in the cervical zones you have these horizontal wrinkles kind of things. These are nothing but perikymeta. Okay? Cracks and neonatal line are very direct. I'll go ahead with that. Then we have enamel lamella that extends from enamel towards the DJ. So you have enamel from surface towards the DJ. You have three types. Type A are composed of the poorly calcified rod segment. Type B are the degenerated epithelial cells, and type C, they are present in the unerupted teeth and they are filled with organic matter. Type A is the only one that is restricted to the enamel. B and C may extend into the dentine. Okay, your A is poorly calcified rod segment, B is degenerated epithelial cells, and C is the one filled with organic matter. Then you have enamel tufts. They are at DJ and they are like grass-like things on DJ. Now, if you see gnarled enamel and enamel tufts, they are it's a bit confusing. But enamel, gnarled enamel is a bit longer. You know, it extends a bit more into the enamel, and it's not as that grass-like. It doesn't exactly appear like small tufts of grasses. Okay, here they are tufts. They are grouped. Very clearly, they are grouped. Then you have enamel spindles. We have already seen enamel spindles. They are the only mesenchymal structures in enamel. These are enamel spindles. No, these are developmental laminae. Let me go ahead and see the enamel spindles. These are the tufts. Yeah, here we see the enamel spindles. Okay, then we have enamel something. Okay, yeah, Himlata has been asking about the enamel cuticle. Yeah, we have the three things about enamel cuticle. Okay, when we talk about the enamel cuticle, you know, do you remember this enamel organ forming the enamel? This enamel organ, after the enamel is formed, it collapses to form a thin layer of epithelium that remains on the crown of the newly formed tooth till it erupts. This is called as reduced enamel epithelium. Okay, this reduced enamel epithelium cells deposits a layer of cuticle that is called as primary enamel cuticle. Once the tooth erupts, this primary enamel cuticle is lost. Then you have the secondary enamel cuticle, that is nothing but the salivary pellicle that deposits on the surface of the tooth. Is that clear? Yeah. And it was a good point rather raised. What I'll do in the next class is I'll rather get up the text directly for you on these points. Okay, it just happened to be missed in the slides. No voice? Is it okay? Yeah. Then we have enamel rod ends. We had been talking about the enamel rods. The ends of the enamel rod, they are concave and shallow in the cervical region, and they are more deep near the occlusal region. We have Nasmyth's membrane that covers the newly erupted tooth, that is a basal lamina-like structure. Then you have the pellicle, that is the precipitate of the salivary proteins. Okay. Then we'll be coming to the oral mucous membrane. We'll be covering up the oral mucous membrane in the next class, and this actually will also include the coverage of gingiva. Let me just see what all we have left for you. Are you able to hear me? Yeah, kind of my system's hanging actually. Anyways, we are at the end of the sessions. Today's session, I think this is enough for now. What I would like you to do is please go through these portions, and if possible also read that keratin chart at least from your gingiva part, because that is very much memory based. I'll explain you the things, but if you read it and come, it will be very easy. Yeah. So especially the ones like K1, K2, K3, K9 and all those things, right? I want you to read those chart and come in the next class. Any other doubts? Anybody needs a voice control to Yeah, Archana, I'm a periodontist. Why is a very tricky question. Not all whys have answer. Why is there a difference? I'm not sure. There is a difference, and what is the difference? Probably I can tell you. Okay. Yeah, Rajshekhar is Comet papers from 2004 to 2010. Yes, correct. And there's one new book from 2011. I think it's Dental Quest or Dental Quest something. Yeah, Gaurav, tell me, what's your question? Thanks, Prajakta. It would be great if it really helps you. Yeah, Prasad, we will be making. Oh, your question, did I miss it? Wait, let me just go back onto the chat window. Let me see. Gaurav, I don't see your question. Can you just copy paste it again? Diagram of Perry. Is that the question? Priyanshu, yes, I have put up that thing of making ComEdK papers online. But I'm not sure right now. I can't promise on my end, but as far as I understand that, yeah, we are all working on towards having the ComEdK papers online for you all. Right, as far as AIPG papers would come online by approximately, I think so, June. And let's see, yeah, we'll be making 2011 paper also available. And these papers which, old papers which would come online, probably they do not have the explanations directly over there. It's for the practice you will be getting these papers. But yes, if you have issues, we'll be rather discussing all these things in the discussion sessions. Prasad, it's there in Dental Quest. There's a new book. You can request that book. It's a new book. I think so. I must be having the reference or the publications of it. If you need that, just write a mail on to. Haha, Gaurav, this thing, primary Dentin and pre-Dentin, please don't get confused with that. Author is this Suresh Shenvi and Gaurav something. Gaurav or Gautam, I'm not sure. Gaurav, I think. Gaurav, this pre-Dentin and primary Dentin, what is making you confused is just don't confuse, don't consider them relatively. Pre-Dentin is a term given to every new layer that is deposited before it gets mineralized. Right? But primary Dentin and secondary Dentin is a classification of already formed Dentin. The Dentin which is already mineralized, we classify into two parts, primary and secondary, based on whether it is formed before the root formation or after the root formation. Does that make it clear? Gaurav, are you sure? Does it make it clear, Gaurav? Yeah, just try reading MCQs of these primary, secondary Dentins. See if it confuses you. See if it still confuses you. I'll make it more clear in the next class if it still confuses you. All of you, please cover up all the MCQs of these topics. Okay? Okay, all. Bye-bye. Good night.